Hi, so today we will talk about gradient. This is our lecture 3 in the series of electromagnetic theory. We have discussed about vector calculus in the last two lectures. Now let's move to the topic called gradient. This is also a mathematical topic, but it is very important to learn the electromagnetic theory, okay? And sometimes there are questions being asked in the GATE exams based upon this gradient also. And it is very important to understand this concept in terms of the intuition, in terms of the geometry, but not in the terms of mathematics, okay? So mathematics is pretty simple, but when you have the intuition behind what is the gradient, then you can solve some theoretical questions which are being asked in the GATE exams related to the gradient. Okay, so let's look at it now. So let's say we are familiar with the xy coordinate till now. Let's say we are given some function called y is equal to x square, and this is the plot for this y is equal to x square. Now let's say we want to find the change in the y when we move from this initial point x is equal to x naught to, let's say, some point which is x is equal to x naught plus h. Okay, here h is tending to 0. That means this is very small. Okay, so sorry for this notification. Okay, so what I'm saying, when this h is tending to 0 and I'm initially at this point x is equal to x naught, and I'm moving to the point x is equal to x naught plus h, then if I want to find the change, what will be the change in this y? Let's say this is called dy, and this distance is, let's say we are calling it dx. So when I'm moving from x is equal to x naught to a dx distance, then what will be the change in the y? We are calling it dy. So how we will calculate it? So this is very simple. We would just find the slope at this point x is equal to x naught. Yes, and then we will multiply it by whatever the distance we are moving from x is equal to x naught. Let's say we are moving dx distance. Okay, so this would be our change in the y. Yes, so here this y is depending only on the function of x, and that's why we can easily calculate the change in the y, okay, by calculating the slope at whatever the point we are initially and whatever the distance we are moving. So this is the distance we are moving from x is equal to x naught. So this would be simply h. Okay, so that is fine. We are familiar with this concept very well. Now let us say instead of giving this y is equal to x square, this function is dependent on x and y. Okay, so this plot is from the Wikipedia, and this is plot for cos square x plus cos square y ka whole square. Now this is not necessary, but just remember this is the function of x and y. This is only important for us now. Okay, so what does that mean? Fxy means when you put any point in the xy plane, you will find a certain amount of z distance. Yes, so this is our y axis and this is our x axis. So this z axis is upward direction. So when you will like put any input x and y, you will find correspondingly the z distance. Okay, let's say this is some point x and y, so you will find this point here. So similarly, for each point in the xy plane, you will find this curve. Okay, now what I'm saying, when I was plotting y is equal to x square, it was very simple to calculate the change in the y because it was the only direction, x was the only direction in which the function was changing. But here, let's say initially I am at this point. Okay, so I am having this height. Okay, this much of height at initially x naught, y naught I have. Now, if I move from this point initially, let's say this is my point A. If I move from point A to in this direction, let's say I went to the point at this point, then I will be having distance by this. So this will be my change, corresponding change. If I, let's say I went to the point x naught plus something h and y naught plus something k. So when I moved from this point A to, let's say this is point B, then corresponding change would be this. Yes, let's say this is my some y1 change. Now instead of going in this direction, let's say I am moving in this direction. Yes, then let's say from point A to I went to the point C, and this is something different point, then I will be getting the height like this. Yes, so now the change would be this much. Yes, so now the change in the Z is depending on the direction, not only on the coordinate or not only on the distance in the xy plane, but the direction in which you are going into the xy plane. Yes, so now it is little complicated here to find the change in the z or the change in the value of this function fxy, because now the change in the function f depends on the direction in which we go from initial point. Yes, if I go into this direction, then there would be different change. If I go into certain different direction, then there would be different change. So there are infinite number of direction in which I can go from this point. Yes, I can go into this or whatever. So there are infinite number of directions. So there are infinite number of possibility of changing the value of f. Now, what is gradient then? So gradient gives me the direction in the xy plane. So let's say I am initially at this point A. Now gradient will give me the direction in this xy plane in which if I go, let's say this is direction given by my gradient. Now if I go in this direction, then I will find the maximum change in the y. Okay, so this is not the exact direction. For example, I am saying if it is the direction of the gradient, later we will see gradient would be the vector. Okay, so gradient will give you the direction in the xy plane for this function. So gradient will give you the direction in which the function is changing at a maximum rate, or the function is changing maximal. Okay, so maximum change is happening in the function's value. Okay, that is fine. So gradient, let me write it. Let me write it here. Gradient gives you the direction of maximum, you can say steep. Yes, maximum steep means the maximum rate of change. So let's say at xy point, initially you are at this point. So if you imagine this graph as a hill, then let's say you are standing initially at this point, Now in which direction you should go that you will see the maximum change in the height. Okay, you want to, let's say, reach at this top point, and initially you are at this point. Now gradient will give you the direction in which this height will be covered, or this height will be reached as soon as possible. Okay, so this, let's say this gradient direction is this, then you will find the maximum change in this y. Okay, that is fine. Now let's look at it in much more details. Let's say I am going in this direction. Okay, so I am going in this direction, and this direction is given by, let's say, s vector. Okay, and let's say initially I am at this point. This is my point A. Okay, now I want to find the change in the y while I am going in this s vector direction. Okay, direction given by this vector. I want to find the change. Okay, now let's say initially I am at the point A, and I went up to the point C. Let's call this point C, and let's say this distance which we covered from A to C is ds. Okay, now when I'm moving from point A to point C and covering this distance s, so there would be some change in the height of this function. So this would be the difference we will be getting while I'm going from point A to point C. Now how to calculate this mathematically? How to calculate this? Here in this 2D graph, it was very simple. We just have to find the slope at that point, initial point, and just multiply that slope with the distance we are going. Now here, this would be the similar concept, but little much of difference is there. So I'm going from point A to point C. I can also write that if I go from point A to, let's say, some point B, and then I go from point B to point C. Okay, so instead of going directly from point A to point C, I'm going from point A to point B. Now just notice just this distance from A to point B is the distance of x-axis. So here we are keeping the y constant and going from point A to point B, and then I'm going to point B to point C while keeping the x constant, and here is y constant. Okay, so the total change from point A to point C, or I would say when I'm going from point A to point C, the total change in this function value, let's say this is h, is equal to the sum of the difference in the function value while I'm going from point A to point B plus I'm going to point B to the point C. So I can write this change in function df as delta f by delta x into dx. Okay, so this distance is my dx, let's say, and this distance is, let's say, my dy. Okay, and this was ds. So instead of going directly from point A to point C, which is ds, I am going first from point A to point B and then from point B to point C. Then the total sum of the change while I'm going to point A to point B plus the change in the function value while I'm going distance dy. So this would be the total change while I'm going from point A to point C. Okay, this will be the change given by point A to point B, and this will be change given by point B to point C. So here we kept the x constant, and here we kept the y constant. So this is also called the partial derivative of the function with respect to the x, and this is the partial derivative of function f with respect to y. So in this way you can find the total change in the function value while first keeping the x constant or y constant, or then x constant. Okay, so this is also called the some theorem in the partial derivative theorem. Okay, so this is partial derivative theorem. So now this is the dot product of two vectors. So I can also write this function df, or the change in the function value f, is equal to del f by del x I cap, or let's say x cap, plus del f by del y by cap dot dx x cap plus dy by cap. Okay, we can also write this equation like this, because when you will simplify this dot product, this is our dot product, then you will get this equation, because like term will be multiplied and the dot product of y and x would be simply 0 because they are perpendicular to each other. So we can write this change in this way. Now this dx x cap plus dy y cap, if you look at this question, this picture, this dx x cap plus dy y cap is simply this vector. Yes, this is simply ds vector. That this vector is the direction in which I am going. Yes, I am going in this direction. So this ds vector is showing me the direction in which I am going. So ds vector is in the direction of, let's say, s vector. Yes. Now the magnitude of this ds, so this is something like this. I am going dx into the x direction and I am going dy into the y direction. So this is my ds vector. Now the magnitude of this ds vector would be simply under root dx square plus dy square. Yes, so I can also write this equation as df by ds is equal to del f by del x x cap plus del f by del y y cap dot dx x cap plus dy y cap divided by ds. Yes, and ds is simply dx ka whole square plus dy ka whole square. Yes, we can also write this. Now this is simply giving me the unit vector. Yes, this would be giving me the unit vector. Let's say this is s cap, because we have divided the vector by its magnitude, because the magnitude of dx x cap plus dy y cap would be simply the dx under root dx square plus dy square. So this is my unit vector. So I can write this change in the f with respect to the s is equal to del f by del x x cap plus del f by del y y cap dot let's say this is my direction S cap. Yes, I can write this. Now this S cap is the direction in which I want to go and the direction in which I want to find the change in the F. Now look at this term. Look at this term carefully. I can write this term as del y del x plus del x cap and del y by cap multiplied by f. Now this f is simply the scalar function, okay? So I can take it out, okay? So now this term is our delta. So we represent this del y del x cap plus del y del y del divided by del y by cap by delta. Okay, so we can write this del f by del s is equal to delta f times s cap. Okay, this is our final equation. So there is nothing mathematics we have done. We have just simplified this change in the f when I'm going into the direction of s. So we have calculated df by ds. Okay, now this is what we call the gradient of function f. Okay, so this is our gradient we were discussing about, and this is the direction in which I am going and in which I want to find a change. So this is df by ds. So this is the same as in which I want to go. Okay, now let's analyze this equation. When I will simplify this dot product, what I will get, del f by del s is equal to delta f ka mod and then s cap ka mod and then cosine of the angle between these two vectors. Okay, just remember this gradient is a vector quantity. Okay, because just look at it, this is in terms of x cap and y cap, so this is the vector. Okay, so this del f would be giving you a vector quantity, and here we are taking the dot product of this vector del f and the unit vector in the direction of s. So this is the angle between the s cap and this del f. Okay, now when this del f by del s will be the maximum, this will be maximum when this theta is equal to 0. Yes, this would be the maximum. Yes, so now we can conclude by this fact that if I go, like s cap is the direction in which I am going, now I can say if I go in the direction of delta f, yes, if I go into the direction of delta f, that means if the theta is 0, yes, then I will be getting delta f by delta s, which is the rate of change in the function value with respect to the s. So we will be getting delta f by delta s maximum when I go into the direction, direction of gradient. Yes, so I will get the maximum rate of change or the maximum slope when I go into the direction of gradient. So I stated initially at the first that gradient will give you the direction in which this function f would be changing maximum. Yes, I initially stated. So I initially stated that gradient gives you the direction of maximum steep or the maximum change or the maximum rate of the change. Okay, that is the one thing. Now second point, if you take uh, let's say if we put the theta is equal to 0, then the delta f by delta s, we will be getting it maximum is equal to delta f ka mod, yes, and this s cap mod will be 1 because this is the unit vector, yes. So now, okay, we said that delta f will be giving you the direction of the maximum steep, but what is that maximum slope? What is that maximum slope? That will be, that we can find it by taking the magnitude of this gradient of f. So finally, let me write two statements. So we will be concluding this lecture by two statements. First, gradient of function which is represented by delta f gives you the direction of maximum ascent or maximum steep or maximum rate of change, whatever you will. So if I go in the direction of delta f, then I will be finding the maximum change in the function value. Okay. Second thing, the magnitude of this gradient gives me the amount of maximum slope. Okay, and third thing, remember delta f is a vector quantity. Okay, it is not a scalar. This function f is a scalar, but when you apply or when you operate this delta operator with this scalar function, then you will be getting the vector quantity. Okay, so these 3 points you just remember. This is all about the gradient. Okay, thank you.